So the objective of this video is to understand integrals resulting in inverse trig functions. Hopefully you've seen the video about derivatives of trig functions, because all the formulas I've written here are just based off of the derivative formulas. So the integral of this will result in inverse sine, the integral of this will result in inverse cos, and the integral of this will result in inverse tan. I won't explain them because they are just building upon the derivatives, so I'll just get right into some example questions. If I look at this expression, I should immediately think it's inverse sine because it's positive, and I have the square root of 4 minus x squared, so that obviously 4 is going to be 2 squared, so this should just be inverse sine of x on 2 plus c. Okay, because that's just 2 squared minus x squared, and if I just use this formula, I'd get this answer. So for some harder examples, sometimes, well, not all the time, you're going to get your coefficient of x squared being 1, so you have to manipulate it using substitutions to get a coefficient in front to be 1. So if I let u equal 4x, I can rewrite this. Before I do that, I'll write du dx equals 4, and then dx equals du on 4. So I can rewrite the entire expression as 3 on root 5 squared minus u squared, because 4x all squared is 16x squared, and then instead of writing dx, I'll write du on 4, and I'll write this as, I'm bringing out 3/4 in the front. Now I have 1 on root 5 squared minus u squared du. And again, if I just use the formula from before for inverse sine, this is just inverse sine of u on 5. U on 5 plus c, and that's going to be inverse sine of 4x on 5 plus c. Just like that. So this example, now that I have a negative sign out in front, I should know that should be inverse cos, right? So if I take out the 2, I can write it like minus 1 on 4 squared minus x squared. And if I just use the formula, I would know that this is 2 inverse cos of 4 x on 4, because this is 4 squared, and then I'll just put plus c, and it's as simple as that. So when you have expressions of some number plus x squared as the denominator, you should think, okay, that's going to be inverse 10. And I could look at this, and maybe some uninformed individual or someone who hasn't learned this properly might look at this and say, okay, well, 9 is 3 squared, and this is x squared, so it's going to be inverse tan of x on 3. But tan differs to sine and cos, because while sine and cos are all have their numerator as 1, tan has its numerator as a. So I need to have it in this form. I can't have it as 1 on a squared plus x squared, because that's not the correct form for inverse tan. So if I'm doing this question, I have to put it as a on a squared plus x squared. So a squared in this case is 9. So I want this to have a 3 on the top to be able to convert it into inverse tan. So what I can do is just take a third out and then put a 3 on the top, and I have the same expression, but now I can take 1/3 out of the integral, and I'll have 1 on x squared plus 3 squared. X squared plus 3 squared. This needs to say 3 actually. And then this expression is going to be 1/3. This whole thing, inverse tan of x on 3 plus c. Okay, so that was an easier example for tan. Occasionally you can get something that looks like this. Now, this doesn't immediately scream, oh, it's going to be inverse tan, but when I see this, you can solve these using completing the square. So remember that for inverse tan, you want you know, a squared plus x squared, but this x could be, you know, x plus 1 squared, or just any linear factor squared, anything like that. So if I complete the square, and if you don't understand it now, hopefully if I explain it a bit more, it'll make more sense. If I take my denominator and I complete the square, I'll have 1 on x squared plus 2x. So I take, when completing the square, I take the x term, the coefficient, 2, I half it, gives me 1, and I square 1, which gives me 1. So I add and subtract 1 like this, and then I have 1 on x squared plus 2x plus 1 is a perfect square. It's x plus 1 squared. And then minus 1 plus 3 is plus 2. And if I write it like, say, 1 on x plus 1 squared plus root 2 squared, if I let x plus 1 equal u, I have an expression that looks like 1 on u squared plus root 2 squared, which is now in the form that can be converted into inverse tan. Du is the same as dx in this case, because the coefficient of x is 1. So if I take this, and remembering when we're doing tan, we can't have a 1 at the top. We need a at the top, so we need root 2 on top. I'll write it as 1 on root 2 u squared plus root 2 squared. So putting that through the formula is 1 on root 2 inverse tan of u on root 2 plus c. And then obviously u was x plus 1, so this is 1 on root 2 inverse tan x plus 1 on root 2 plus c. And just as a final example, this completing the square method can also be used for cos and sine. So again, here I have my square root, 8x minus 4x squared, which is not in the form for, not in the right form for cos and sine. But if I just complete the square, so I'm going to take out the factor first. I can take out 4, so this is 2x minus x squared. And this will be, the square root of 4 is 2, so I can take it out. 2x minus x squared. Now I want to complete the square with this. So what I'm going to do is make it easier for me. Put a negative sign at the front. So negative x squared minus 2x. And maybe I'll do this to the side. Instead of writing out the integral sign of dx every time, I'm just going to focus on what's inside here. So I have negative x squared minus 2x. I want to complete the square, so I take the coefficient of the middle term, the coefficient of the x term, I half it and I square it. So half of negative 2 is negative 1, and I square negative 1, which gives me 1. So I add and I subtract 1. And now I have x squared minus 2x plus 1, which is a perfect square. That's x minus 1 squared, and this is minus 1. So then if I get rid of all the brackets, I'll have minus x minus 1 squared plus 1. Or then if I put this back into here, I'll get 1 on negative 2 square root. So whatever was under the square root here is equal to this, 1 minus x minus 1 squared. I'll take out this 2, so I'll write it like half square root minus 1 on root 1 minus x minus 1 squared. And if I let u equal x minus 1, it'll soon be in the form for inverse cos or inverse sine, right? So I go here, I'll have half negative 1 on square root 1 minus u squared du. And if I look at this, I should think, okay, there's a negative out front, square root of 1 squared minus u squared, this should be inverse cos. So that is the same thing as half inverse cos of u on 1, which is just u, plus c, and then this will become half inverse cos of x plus 1, sorry, not x plus 1, x minus 1, plus c. And that would be my final answer. So that's the end of this lesson. I hope it was helpful for you.